This is Chapter 8, Univariate Data Analysis, Section A.2, question number 3. So many students were struggling with this question, so I wanted to review it with everybody. I'll just kind of summarize the question. So Warren decided to do an analysis of the population, and he looked at 3 different years, and he was trying to see if family sizes were going down and if overall the population was at an all-time low. So he looked at 3 different years, 1935, 1960, 1985, and was looking at how many people per household there was. So the first question said, find the population sizes of the town in 1935 for the first one, 1960 for the second one, and 1985. So if we look at we're looking at 1935. Many people probably would have just added these up and realized that you didn't get the right answer. So what do you need to do, I guess, is your question. Well, this data is telling you that there are 9 houses that have 1 person in them. There are 68 houses that have 2 people in them, 73 that have 3, and so on. So what we have to do when we're adding up the total population size, we'll say total pop equals, and we're going to use brackets, 1 times 9 plus 2 times 68 plus 3 times 73. That's 73 plus 4 times 109. I'm going to run out of space. Plus 5 times 178. And if you added all of that up, you would get 1690. And you're going to notice that in the back of the book, it actually says greater than or equal to 1690. And the reason for that is because if we look at the last row, it says 5 plus. So we don't know if some of these houses have more than 5. Some could have 6, some could have 7. So that data, we don't know the definite answer. We can just say it's going to be more than or equal to 1690. Now, we would do the same thing for question A2, and I'll just go through this quickly. So it'd be 1 times 8 plus 2 times 177 plus 3 times 162 plus 4 times 374 plus 5 times 283. And you'll notice just by looking at those numbers that this is probably going to be bigger than the 1935 population, which is true. So this was 3759. And again, this was greater than or equal to. And then we go on to the third one. Total pop equals, and we have 1 times 69. So look how many more people are living by themselves. 2 times 184. 3 times 248. 4 times 162. And 5 times 38. And that's a huge drop. And so our total for this one is 2019. And again, it's greater than or equal to. So that is question A. For question 3B, preparing a table of percentages for the town's population data, the first thing that you need to do is to look at each column. So if we look at 1935, we have the number of households that were a part of this census. census, sorry. So we need to add those up. So if we add those up, we should get 437. And then we're going to do the same for 1960. I'll just highlight that. So again, these are number of households. And so this one would be 1,004. And then we will do it once more for 1985. Add those up. And it is 701. So you see that huge drop between 1960 and 1985. 701. So the question is asking us to prepare a table of percentages. So rather than having numbers there, it wants to have percentage data. Now that we have our totals, we can go through and find our percentages. So we're going to start off with 9 and divide it into 437. And then times by 100 so that we get our percentage. And that should get us 2.1%. And I'm just going to start a little table over here. We'll say 1935. And then we're going to take 68 and divide it into 437 times 100. That should give us 15.6%. And we'll continue our little table. And keep going. We'll go 73 into 437 times 100. And that should give us 16.7%. Now, if you were to keep doing that for every single one, you would get the data for each year, and you would have a big table like the back of the book. Remember, you're dividing it into the total number of households, not the total population, and you need to multiply by 100 to get your answer. So I'll just finish the 1935 column. So this should say 24.9% and then 40.7%. And the important thing is that once you add up all of those percents, you should get 100%. So this is page 175, 3AB.